Hello everyone. So today we are going to see another simple problem, valid anagram. So we are given input of two strings yes and t, and we are going to return a boolean value. That is, if the strings are matching, then we are going to return true. If not, we are going to return false. So let's understand this with an example. Here's our example strings yes and t. We are going to check if it is an anagram. If it is an anagram, we are going to return true. If not, we are going to return false. So how do we say this is an anagram? That is, the word yes should have the characters present in word t but not in order. They'll be shuffled. For example, if we are taking an example R A T and ATR, both the words are having same characters but they are shuffled. In this case, they both are said to be anagrams. So now our first approach is going to be sorting. We are going to sort these two arrays into a character array and compare each character to find whether it is an anagram or not. So if we are sorting yes, the yes is going to become A, 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 and then comes G, and then comes N, and then M, N, and R. Again, if you are going to sort the text T, it is again going to become A, and then G, and M, and N, finally R. So if you compare string T and S, they are going to have same characters at the same position because we have sorted the string. In this case, if this matches, then it is an anagram. If not, it is not an anagram. Simple. Our first solution is going to take the time complexity of big O of n log n, where n is the length of the string and log n time is going to take because of the sorting process, and n is going to take because we are going to compare the two strings. So how do we make this algorithm work in linear time? Now our second approach is going to be hash table. So what does a hash table do? It is going to give us access to access the character of the string in linear time. So we are going to keep a count of each character in our hash table. That is, we are going to have an array of count. We're going to have count of A. How many counts of A in string yes? It is going to be 3. And then there comes B, C, and goes till count of G. Count of G is going to be 1, and count of M is going to be 1 again, N is going to be 1 again, and R is going to be 1 again. So now we are going to iterate the string T and decrement the values which are present in the string T. For example, we just started to iterate our string T, starts with character N, it goes to character N and decrement the value. Now character N becomes 0, and goes to A and decrement it to 2, and goes to G, it decrement it to 0, and A again becomes 1, and goes back to R and becomes 0, and A becomes 0, and M also becomes 0. So now this array completely filled with zeros, which means the number of characters encountered in string S are same as that of the characters present in string T. In this case, we are going to return true. If not, we have any values more than 0, in that case it is going to be more characters present in T than yes. In this case, they are not going to hold same number of characters, then it is going to be false. So this algorithm is going to run in big O of n time. That is, we are going to just iterate two characters only once, and n is the length of the strings given. So let's code and see how it is going to work. As we have seen examples already, let's go to code. So as I said, I'm gonna iterate my strings and put my value in count array. And I'm gonna check basic condition. If the length of string yes is not going to match the length of string t, then it is not going to be anagram, because we have to have equal number of same characters in both the strings. Now we're gonna iterate our string yes. Now we have incremented our count array in the respective characters position. Now we are going to iterate to our second string t. So now we are decrementing the values once we iterate our string 2. Once that is done, we are going to compare if any of the values in count array is greater than 0, then return false. If not, return true. Let's run. Let's submit. Yes, the solution is accepted and it runs in 1 millisecond. So thanks for watching. Thank you.